All right. Well, Paul is one of the technical leaders at the as well as on the board of the National Space Society and the executive vice president and chair of the policy committee. Look forward to your talk here, Paul. You'll have to select it. On the key here. You've got all three.
Okay. Oh, it's on the key. It's not on the computer? No. Okay, so I got to do that. Okay. I can do that. Jeez, I should have brought my own key. I do have my own key, but since this one is physically out, I don't want to take people's time. There we go. Let me say, I'm really sorry that I missed John's talk. Although having studied his book, studied his report, and studied the book before that, I can guess some of what he talked about. I had to be in another room because as chair of the policy committee, we wanted to talk about the policy track. And space solar power is an issue of central importance to the larger policy goals of NSS. So it's appropriate that it be discussed both in this track and in the policy track, even though that causes a few logistics problems. In this track, well, in the other track, I promised to talk about why space solar power is crucial to the goal of the human settlement of space, and why everybody who cares about the human settlement of space should read John's book and follow up. That's my next talk, okay? Tomorrow, we're going to get into the real technical obstacles. And maybe I'll talk just a little bit about them as time permits.
Right way.
So the question is, if I'm going to be talking about the technical details tomorrow and what it matters to space in the next talk, what do I talk about now? I was thinking, well, maybe I should talk a little bit about why this is important for Earth. Okay? And there are a lot of people who have made this case in a way that wouldn't survive very well in the very serious policy sessions of Washington, D.C., or the international community of any nation on the Earth. There is a good case for space solar power looking more and more important to our future on Earth. The case has been getting much better with time. But there are a lot of people who engage in wishful thinking and distort the case. And that sometimes causes us problems in Washington. So I'll try to give at least my version of this case. I should say a little bit about my day job. As Gary hinted, I wear about 20 hats. I am actually officially speaking for NSS. It's the first time in my life I can remember being able to say, hey, what I say are actually the official views of this organization by the bylaws, if you believe the bylaws. But they're certainly not the official views of the National Space Society, where I run a little program called Energy, Power, and Adaptive Systems. I used to build the large econometric models that the Department of Energy used to predict the energy future of the world. And when you've had to fight real numbers in the real energy economy, one of the first things you learn is not to believe 99% of what you hear in Washington. There are a lot of liar games out there. And my personal opinion is, oops.
Can you put it up to full screen?
Oh, full screen. Okay, full screen. Okay. Okay. My personal view is, if you win by distortion, you destroy what you're planning to sell. I saw that happen with fuel cell cars. I have to confess, I was probably the key guy who sold Gore and Clinton on the idea of a fuel cell car program. And I was invited to the White House when they started inaugurating it. But then they turned it over to political lobbyists and activists who said, we need team players. You're saying there are problems we have to solve. We have to be politically practical and get rid of all this discussion of problems. And they spent a few $1 billion, but they were unable to focus money on solving the problems. I think fuel cell cars could have been much better than they were. But all the political propaganda got in the way of solving the problems. So you can get billions of dollars and hurt your cause. What you buy for the money can be negative. And I've seen that happen in space too. So when we talk about energy, we need to get it right. In fact, let me be honest. I was delighted to have a chance to try to help up Boeing and the space community when they made a big push in Texas a few years ago to try to sell space solar power. And they had a game plan. We'll try to sell Exxon on becoming the leader of this, and our game plan is we'll tell them you're running out of oil and you need something new. Now, I knew enough about the oil industry to know that was not a good case to make. But I didn't want to scream at Boeing. I wanted to be a team player. But there are times, if you want to help Boeing, you got to speak truth to power. And you got to say, look, I wish I had said to these guys, look, I know the oil industry. This isn't the way you sell space solar power. And if you tell the oil industry you're running out of oil in 10 years, they're going to laugh at you. And if you say that you can use energy from space to power people's cars, they're really going to laugh at you. And there are a lot of people in this community who say things which make real energy economists laugh. And we've got to be careful about that. But being a real energy economist, I've been slowly convinced that it's more than a high-risk adventure. I have to say, I've been tracking this to some extent for many, many years. I'll talk more about some of these detailed things tomorrow. But when John and I did the last U.S. government funding effort, the last open funding competition in space solar power was run jointly by John Mankins and myself. Physically, NSF did the paperwork, but NASA did a whole lot of things like a grantees meeting that was really important. At the end of that, the best life cycle cost estimates were on the order of 17 cents per kilowatt hour, and that's if everything works. And the details of those cost estimates were a little bit hard to find if you're a scholarly kind of person. In the last 10 years, I've seen more and more estimates that look better and better and more imaginative with less and less really provable documentation. So that until about 2 years ago, I was mainly citing the old stuff. And I said, okay, this is a high-risk possibility, but when I really talk about the real-world energy economy, it really wasn't the first thing I would usually talk about. I'd kind of say we got to put money into high-risk possibilities. That was the case, that we got to put money into high-risk possibilities. But now we are in a new world. As of this past year, we are in a new world, and we owe huge thanks to John Mankins and the folks John has worked with. Now, it's not like we're all born omniscient. I've seen earlier work by John that was not as convincing to me, even though he put in a lot of work. But his recent report for NIAC and his new book changed the world. And I really urge, at the very least, I have an article in Ad Astra that reviews his book, talks about why it's important and what to do about it. So if you guys are interested in advancing space solar power, please look at Ad Astra. And every word counts because it's a big and complicated area. But right now, we have new hope. The reason I thought 17 cents a kilowatt hour was too much, this is kind of a rough graph of what people are paying for electricity. Most of the world is paying on the order of 10 cents or less. But the European Union, in particular, and Japan, is paying more than 17 cents, but you've got to consider there's a grid in there. That's not the generating cost. And that's part of why I wasn't really so optimistic until the new stuff came from John. This is what excites me. I would have said about 6 months ago, I am more optimistic about space solar power becoming real than I ever was in 20 years tracking it closely. Because things change, and we have new things. And one of the new things, you probably heard about it from John, he did a NIAC report and now his book. One of the things I like about the book is that actually he says where his cost estimates come from. And if you study the book, there are two things you can see. One, they are the very best cost estimates now available given what we presently know. They're the best you can do with what we know now. They're also good, but also at this early stage, at the low TRL level, of course we don't know what the real costs are going to be. You don't know that till you start bending metal and proving things. But the cost estimates are well defined, they're the best you can do, and they are looking much better than the earlier cost estimates. There are lots of concepts of space solar power. There was one where Boeing once said it would cost 5.5 cents a kilowatt hour years ago. I was part of the DOE review team that looked at it and said, we don't believe it. You should do research, but the numbers are not real, and they were not real. And later, John Mankins himself played a critical role at NASA in showing why those designs wouldn't even work at all in the first generation. The next generation designs look real good. A lot of people still believe them. The costs were 17 cents by a tough cost methodology. But that same tough cost methodology is saying we have a new design, and a new design changes the costs, and the estimate is 9 cents a kilowatt hour if we can get launch costs down to $500 kilogram LEO. And if you can get 9 cents a kilowatt hour any place on Earth, that could change the future of humanity. So let's not play for small potatoes. Each day we have to think about small potatoes to stay alive. But if we want to win in the long term, we got to focus on the target. If we have a chance of getting to 9 cents a kilowatt hour for humanity, this is of huge importance to humanity, and we really shouldn't lose it. We should latch onto this like the steel trap. Let's not lose our 9 cents a kilowatt hour baseload power. The world needs it for many reasons. It would make costs of electricity lower this week in Europe if you could deliver it this week in Europe. It would also make electricity available in places which don't have the kind of solar power and wind that the U.S. is blessed with. And there are people I know in Washington who would say, wait a minute, do we want to invest money on something that's needed by other countries like India and China and Iran? Why do we care about them? And I'd say, think about it, guys. I would like Iran to be able to buy baseload electricity cheaper than fusion so that they don't have to buy fission plants. And then people say, why do you care whether Iran buys fission plants? Why should the U.S. care about that? And I say, yeah, we need to learn something about national security, okay? So 9 cents a kilowatt hour could be a great boon, but you have to get launch costs down to $500 per kilogram LEO. And John's book is pretty explicit that you have to do that. Now, I have to confess, the part of the book where he talks about launch costs, there is some other information we have on launch costs. And when I ask what the primary policy priorities should be for NSS here and now, my feeling is one should be exactly doing the space solar power research that John's plan calls for, or logically implies, to get to the 9 cents. But equally important is getting the launch cost down to $500 kilogram LEO. And I funded a lot of work related to launch, and I've seen what other agencies have done. I am 100% convinced we can get to $500 kilogram LEO or less, which is what John requires. I can back that up, and tomorrow I'll talk about that in some detail. It won't happen automatically. And we need people here to work hard to make sure that $500 per kilogram LEO really happens. That's a big challenge politically. In fact, that's going to be the biggest part of this. And I'm still not full of optimism. I still worry the whole human species may die. But let's try, and let's focus on what we need. $500 per kilogram LEO and fulfilling the potential of John Mankins' plan. Those are two key priorities. Now, you'll notice the other thing that made me really excited a few months ago was a new program at DARPA called XS1. And I'm really happy that Jess Sponable is going to be here today and that Mitchell Clapp is going to be here today. Those two people from DARPA, Jess Sponable and Mitchell Clapp, in some ways, they are our best hope of getting to the $500 per kilogram LEO. It's not the Senate launch system that's going to get us there, okay? It's not going to get us to anything like that. There's no hope of an expendable rocket getting us to those levels. But with really advanced technology for re-entry vehicles, which solves the real structural problems that guys like SpaceX have not really fully caught on to, we need advanced technology development to make that happen. I won't say DARPA is 100% on top of that problem, but they've got real money working the problem. at least finally the U.S. is somewhat on board, and certainly it's possible. Now, electricity. Since I have sometimes earned a living as an energy economist, and since I've seen a lot of really phony numbers, I'm going to give you some rough order numbers. And they're rough, but nobody has 6-digit numbers that are real anyway, okay? And I put together 6-digit numbers in giant computer programs. I know how that works, but the rough numbers are actually more reliable. There are two groups called IEA and OECD. This is like the Bible in a lot of energy. They've put out data on how much electricity the world generates. The most recent data is like 5 years old, but it was 20 terawatt hours per year. The IEEE people I work with say, yeah, electricity today, we're really talking about 10 cents a kilowatt hour. So what we're talking about is $2 trillion a year right now. So if you want a big market for space, $2 trillion a year out of a world GNP of 70 trillion. What do the other things cost? ARPA-E has a target of getting down to 5 cents a kilowatt hour for PV farms. It's nice to have ambitious targets. But I have to say our $500 per kilogram LEO is a much more clearly defined achievable target than their 5 cents. It's a nice research goal, but the real cost is like 20 cents a kilowatt hour for wind. For solar farms. For wind, which is the other large-scale renewable in the U.S., right now you can make wind at 7 cents a kilowatt hour in the Midwest, but people aren't doing it because the political obstacles are so severe that right now people are putting in wind farms offshore where it runs more than 20 cents. What's more, this doesn't follow the load curve. Anybody who knows electric power knows the load curve is sort of like the center of all human existence. Okay? There are times of day people want electricity, there are times of day they want less, and it's a little hard to predict. I've done some quick calculations based on the official DOE numbers for compressed air storage and the very best numbers for lithium-ion batteries available for China, half the price of what you get in the US. And either way, storage basically would add 10 cents a kilowatt hour on top of the generation cost. And then you got to put it in the grid. And with today's power grid, the estimates I heard are at about 20 cents more. So what if renewable energy basically requires you to spend 50 cents a kilowatt hour at the end of the day instead of 10 cents? What if the bill for electricity, instead of being $2 trillion, is $10 trillion a year? And what if you try to go to Congress and the poor people of the world, go to these starving people in India and say, we want another $8 trillion from you guys? You know how likely you are to succeed in that kind of politics? You know, I mean, even in the United States, asking for 50% more is a little hard sometimes for electricity bills. So the bottom line is 50 cents a kilowatt hour, if that's your only way to get renewable energy, you're in deep trouble. Now, at NSF, I've been trying to fund work on the intelligent grid to make it easier for the grid to incorporate solar and wind. I believe the technology is there to make it possible. But I believe that the political barriers to doing it are worse than the barriers to space solar power. You think space solar power is a hard sell politically? You try to remake every electric utility in the U.S. And I say that as someone who is right now under really heavy political pressure because there are a lot of people who just do not want to reform the grid and their power is just unbelievable. I could tell you some real horror stories and I'm really worried about it. Right now, what hits me, the most exciting possibility is if we had a combination of space solar power and the low-cost kind of solar farms in areas of reliable sun, at least for places like the U.S., you don't really need as much storage because your load curve is like this, and space solar power can give you the base, sun can give you the peak, and there's some things you can do with demand on the residual. The cost of storage is reduced by a factor of 10, and to assimilate on the grid is easy. So the bottom line is, right now, given the huge problems with getting a truly intelligent grid, given that the politics is just modernizing wires, given all of these problems, space solar power and solar farms are a really serious candidate even for the U.S., let alone Iran. So my final slide is a little truth in advertising. a lot of what I've said so far, maybe I could call it the official views of NSS. Under the bylaws, I could get away with saying that, right? But now I'm going to give you my personal controversial viewpoints. Truth in advertising. You know, a lot of lobbyists don't tell the truth, and as I say, I think that hurts their cause. I believe each of us has a moral duty to say personally why we think it's important, above and beyond the political justifications. Personally, why I think energy from space is important for Earth, there are basically two reasons. One, I think we're going to need this enabling technology for vital things we do not really know about yet. And I can't talk about it all. A lot of funny things coming up, but that's one of my real reasons. We really need the technology. The other reason, I've been very involved in some global futures things. The thing called the Millennium Project, www.themp.org. It's the #1 world international discussion of policymakers on the future of humanity, truly international. There's also a group called the Lifeboat Foundation, specifically focused on the issue of risks of extinction of the human species. And there's even a little group that used to be more active called Foundation for the Future, funded by a guy named Kistler. Have any of you heard of Kistler? Okay, yeah. Kistler and his friend Bob Citron were among the first really big-scale space entrepreneurs. And Kistler is still around, but he's a shadow of the incredible venture he used to be pushing. It's probably scary that he's only a shadow of it because it was an important venture. But he put together Foundation for the Future, philanthropic independent activity, and he brought together all of the people that he thought were the world's top futurists, the people best equipped to describe what is the real fate of humanity on Earth and also in space. And Barbara Hubbard was one of the people there. And in that meeting, at the end, they concluded with a great debate. In this seminar in Humanity 3000, will humanity even be here in the year 3000, considering all the things we know? Will humans even be alive in the year 3000? And they divided the audience up into two groups. They said, you must choose either yes or no. Humanity will be here in the year 3000. Give 5 minutes of debate for your position. And almost everybody divided it up 50-50. I got into trouble, as usual. I'm the crazy person in the middle. The normal sane people are either crazy left or crazy right, and who's this weird guy in the middle? Who could believe the truth is in the middle? So I got up and I said, I think this is irresponsible. It's irresponsible to say humanity will be here or that it won't be here. There's a probability. And the essence of our challenge is to maximize the probability we are still here in 3000. We need to focus on that. And I've been part of that dialogue for many years. And the question is, what is the biggest threat, approximately, of extinction of the human species? My personal view is the two biggest threats to the very survival of the human species are the two I'm listing here. One of them has to do with nuclear proliferation and terrorism, and one of them has to do with climate change, guys. Sorry about that. With nuclear proliferation and terrorism, I used to work on that a little bit when I was at DOE. For the last 3 years, I've had a rather strange role. I learned a lot, but I'm glad I gave it up. I was the coordinator of an interagency initiative between NSF and the Defense Nuclear Detection Organization in Homeland Security. And the first part of that was a real eye-opener. They gave me briefings of the real strategy of the U.S. to protect our people from nuclear bombs going off in Los Angeles, New York, Washington, D.C., Chicago. There are people who want to do it, who are motivated, and are smart enough to do it. And not only that, the U.S. is not the only country at risk. I'd say there are only 2 or 3 small countries that have borders that are safer than ours. Everybody else, it's as bad or worse. When I looked at what the story is, it's scary. Anybody who thinks that nuclear bombs start killing people because they went out of fashion, nuclear physics doesn't care about the latest fashion. Crazy people don't care about being politically correct. The only reason we haven't had nuclear weapons blow up in our face already in this country is because there has been a controlled and limited source of nuclear material because of the relatively small amount of nuclear material generation in the world. And many people want to multiply that by 100-fold. Many people want to build small nuclear reactors in places like Iran. And they say, don't worry, they won't extract the bomb-grade material. Why not? Well, because if somebody went and extracted the material, that person would die of radiation poisoning. And we all know there's nobody in Al-Qaeda who would be willing to sacrifice their life. I mean, yeah, right. Okay? Can you imagine people are making decisions for the survival of this country based on assumptions like that? They guard the borders and they'll say, oh, but there's a 10% chance we'll catch them. That's a deterrent, right? You think someone from Al-Qaeda cares if there's a 10% chance they'll be in jail? These guys need to wake up. The only way we're going to prevent this nuclear proliferation thing from becoming really lethal, in my opinion, is if we have a competing baseload source of electricity, which is a lot safer and is sold by the international community. So the countries like Iran will buy it and trust it. So it can't be just a U.S. effort. It has to be international to work. But the other thing I'm worried about is carbon dioxide. And John was always talking about carbon dioxide years ago. And I used to say, well, we're going to run out of fossil fuels sooner or later. We got to be prepared for it. I wasn't as worried about carbon dioxide. And I looked at the IPCC reports, and they said if you continue with business as usual, you could lose 5% of your GNP. I said, gee, we already lost that last year due to financial regulation. There are higher priorities here. But I have studied this in some detail. Ironically, I owe some of the credit to Senator Inhofe. Okay. I was working with the Senate, the EPW committee, in a Republican office, and I worked closely with these guys. I studied both sides. I learned the facts. And what I learned is that the climate change problems are much worse than you've heard. I wish we had time to talk about it. But from the front lines, from my own personal direct study of the science, I'm convinced that the problems associated with CO2 are far worse than you have heard. Much worse. They're not certain, but a 25% probability that we all die. Okay? They're associated with mechanisms that involve the H2S in the ocean. If you look at the slide, you'll see a brief summary. But I got to run. I got to apologize for taking so much time and run to why space needs space solar power. Thank you for your patience and good luck.
For the two people in the room in the far corner that don't know who I am, I'm Gary Barnhart. In my current capacity here, I'm speaking as the President and Chief Executive Officer of my startup company, Extraordinary Innovative Space Partnerships, Inc. Basically, what we're trying to do is help fill a high-quality pipeline of technology development missions for the International Space Station, working on technology that's at the